Hi, welcome to Algebra Examples. I'm Dr. Finch. Let's look at our example for today. We're going to be talking about composition of functions as well as finding the domain of a function. So remember, the domain of a function is basically the numbers that we can put into a function, the things that we can feed to a function that is capable of digesting. So we're going to start off with two functions. We have f of x is equal to x negative x squared, and we have g of x is equal to the square root of x. Now there's this little caveat behind the g of x. Notice it says if x is bigger than or equal to 0. Remember, if we put a negative sign into our g of x, so you put like a -1 under that square root, all of a sudden you're talking about imaginary numbers, which leads us to complex numbers. And you probably will experience some problems with complex numbers at some point in an algebra class. But at this point, we want to talk about just real numbers here. So we're going to keep this all real numbers. These are just the normal integers and fractions and decimals and irrational numbers that you're used to seeing, like pi. So we're going to keep it to those nice numbers, nothing with like a -1. Okay, we are also going to let h of x is equal to f of g of x. Now, I do want to point out that some of you may see this as f little circle g of x. This is a composition of functions, so it means that we are taking and we are putting two functions together. This is a different way of combining functions. You can think of this as a different binary operation. You know, when we have integers, we add, subtract, multiply, and divide. Now we're talking about functions, and not only can we add, subtract, multiply, and divide functions, we can also have this new binary operation that we call composition. All right, our question for the day, we want to find our formula for h of x and describe the domain of h of x. So in this situation, h of x, whenever we have the f little circle of g, it just means f eats g of x. Okay. And instead of popping g of x in here, now we can look at what g of x is equal to and just punch that in. So we're going to have f is eating square root of x. Now notice at this point, we know that x has to be bigger than or equal to 0 for f to start eating that. The next thing that we do is we're going to take and notice that when we work with f of x, what we're going to do is take the thing that f eats, and we're going to add a negative sign out front and a squared up top. Everything else, I'm going to put parentheses around it because that is the best thing that can help us is using our parentheses. They are our friend. Now, you may remember that the square root and the squared are, in a sense, opposite functions. They're going to cancel each other out. Here's another way to see it if you haven't seen it in a while. We can take x to the 1/2 power because square root is the same as 1/2. And now what we can do when we have a to the b to the c, I will reminder or recall one of our algebra things that we use, x to the a to the b, is x to the a times b. So our exponents are actually multiplied. So this is 1/2 times 2, and our 2's will cancel, which gives us a negative x to the first power. So when we put this all together for our formula, h of x actually spits out negative x as an outcome. Now we do have a caveat. We have to know the domain of this function. And we'll notice that since g of x can only eat positive and 0 numbers, our h of x also can only digest numbers that are bigger than or equal to 0. If, for example, we tried to put a negative number into h of x, let's see. Let's just try -1. We'll do a nice number like that. It looks like if you just looked at this formula, you'd say, oh, I could do it because h of -1 be negative of -1, which is +1. But that is lies because this is a simplified formula. We're not seeing the bigger picture of what actually is happening because when we punch -1 in, we're actually taking the square root of it first. And this one stops us because we don't want to be going into imaginary numbers or complex numbers. All right, so there we have our solution. H of x is equal to -x, and our domain is all x bigger than or equal to 1. I hope you enjoyed listening. Thank you.